Okay, for this problem we're going to use the powers of derivatives to find the equation of the tangent line for f of x equals x squared plus 1 over x plus 1 at x equals 1. Now, if you're thinking we could factor that and cancel some stuff out and make the function easier, wrong. You cannot factor x squared plus 1. X squared minus 1 would factor nicely, but x squared plus 1 does not. So, the first thing I'm going to do, since I want the equation of the tangent line, before I even take a derivative, I know I'm going to need a y value. So I'm going to show that I'm calculating the y value. It's important that you show this, especially on a quiz or a test, simply because if you make a mistake, there's no way I'm going to know what you did if you simply just write down y equals 7. It doesn't equal 7, but if you write that down, I'm not going to know where 7 comes from. By showing me this work, I know what you're doing, and everything is good. So 1 squared is 1, plus 1 is 2, 1 plus 1 is 2, 2 divided by 2 is 1. So not only do I have that x equals 1, but I also have that y equals 1. Now I'm going to go ahead and take a derivative. So that part is done. I don't need to worry about that anymore. I need the derivative in order to get the slope. So I'm going to have to use the quotient rule. So the numerator, which I'll highlight in red, that is my f of x. And then the denominator, let's highlight that one in green. The denominator, that's my g of x. So, the quotient rule says to take the denominator, g of x, the green, which is x plus 1, and multiply by the derivative of the numerator, the derivative of the red, the derivative of x squared plus 1, according to the power rule, is 2x. The derivative of plus 1 is 0, and so that's all you have for that derivative, minus. Now we're going to take the numerator, the red, f of x, x squared plus 1, and multiply by the derivative of the denominator. The derivative of x plus 1 is 1, because the derivative of x is 1, and the derivative of 1 is 0. And all of that, do not forget this part. This is the part that everybody always forgets. All of that is over x plus 1 squared. People forget this part. Think about it. It's a quotient. You need a quotient for your derivative. Then we're going to clean this all up. Now, the rest of this is just algebra. You could say that, here's my derivative, I'm done. I don't need to clean this up. And realistically, you don't. You are just plugging in soon, but I'm going to clean it up because it's good practice. So if we clean it up, I would distribute the 2x to get 2x squared plus 2x, and then distribute the negative 1 to get minus x squared minus 1, and all of that is still over x plus 1 squared. And then finishing cleaning that up, 2x squared minus x squared is x squared plus 2x minus 1, and that is all over x plus 1 quantity squared. That is your derivative. Now, you might be thinking, oh, I can factor x squared plus 2x minus 1 and cancel some things out. Again, wrong. If that were x squared plus 2x plus 1, you could, but it's not. So now that I have the derivative, I need to utilize that derivative to get my slope. So let's get rid of this work here, as well as this work here. So that way we have the room that we need. There we go. Now, this is still equal to f prime of x. We'll just keep that down here. We're going to plug in 1, because that's where we want the tangent line. So I plug 1 into the derivative. When I plug 1 into the derivative, I'm going to have 1 squared plus 2 times 1 minus 1. All of that is going to be over the quantity 1 plus 1 squared. So in the numerator, I get 1 plus 2 is 3, minus 1 is 2. In the denominator, 1 plus 1 is 2 squared is 4. We can reduce that fraction. We should definitely reduce that. So now we've got 1/2. And so then I can write the equation of my tangent line. There's no need for this derivative to be here anymore, so let me just get rid of that so I can write my final answer. My final answer is going to be the equation of a line. So the equation of a line is y minus my y value. My y value is 1, equals m, my slope, that's 1/2, times x minus my x value. My x value is also 1. And this is the equation of the tangent line for f of x equals x squared plus 1 over x plus 1 at x equals 1. Now, you could easily graph this. You could graph the function, graph the derivative, and you would totally see that, hey, this tangent line intersects right there. Perfect.